This week we're going to start off our unit on electricity and magnetism, and we're going to start off by talking about static electricity. You guys probably know a little bit about the effects of static electricity. You've had maybe static cling, or you've had a bad hair day, or you've looked like this guy down in the bottom right corner here. So we're going to talk about how that works. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. First thing we need to understand about electricity in general is that electricity is the flow of electrons due to the force of charged particles. So first of all, you might notice that it is called electricity and that it is the flow of electrons. That's not a coincidence. That's why it's called electricity. So I guess we should probably start off by reviewing a little bit of stuff about atoms. This is something you've probably already learned about in past years of school, what an atom is made out of, and it's made out of different parts. So let's go over that a little bit first, because that's going to be really important for us to understand this. So parts of an atom. This might look familiar to you. So you might know that one is an electron, and we have in the center, we have protons, and we also have neutrons, and that center portion is called the nucleus of the atom. So now the question is, which of those particles have a charge to them? Well, the electrons have a negative charge and the protons have a positive charge. This idea of charge is a little bit of a tricky one. It basically just means that they exert a force on things around them, and we know all about forces at this point. So it's a little bit tricky to talk about that and really explain that, and that gets kind of complicated. We'll get more into that later on in the year, but for right now, just understand that protons are positive and electrons are negative, and all that means is that they are oppositely charged from each other. They are opposites of each other. Protons are positive. Proton starts with a P, positive starts with a P. That's a good way of remembering it. And electrons are negative. And notice the fact that the electrons are on the outside part of the atom. The protons and neutrons are on the inside part of the atom, but the electrons are kind of out here on the outside. And that's kind of important too, because the electrons being on the outside are the things that can kind of get plucked off of the outside of the atom and can move around. And that's a key part of electricity. So just to make sure that we got this part, because this is really, really important here. This is a diagram of the most basic, simple atom that there is. It has one proton and one electron, and we call this atom hydrogen. So label your diagram in your notes, and just remember, make sure that you remember that protons are positive and electrons are negative. That's what this is all about. Protons are positive, electrons are negative. Did I say that enough times? Okay. All right. So let's talk about how static electricity actually works and what it is that's making this happen. I have a few pictures here that might be something familiar to you about static electricity. You might have gotten a shock one time. You might have shocked your little brother or sister or something like that. After rubbing your feet on the carpet, you may have experienced what they call static cling at some point when all your clothes stick together or stick to you. You might have had a bad hair day like this young man right here and had your hair get all frizzy or something like that. So the question is, why does this stuff happen? Well, first of all, let's think about the fact that in order for this to happen right here, this little shock to happen, that it seems like that's kind of like electricity right there, right? So it kind of seems like the electricity has to jump from your finger to the doorknob, either that way, or from the doorknob to your finger, one or the other, right? And so it has to be kind of pulled or pushed from one place to the other place. We also have something sticking to something else, something being kind of pulled and stuck to something else here. And we have this idea that your hair is kind of standing up on end here because maybe they are pushing away from each other. So think about this idea of pushes and pulls, and take a look at this clip here.
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how electrons can be moved from one insulator to another if we rub them together, and that's called static electricity. And then go on to explain how there can be a force of attraction between opposite charges and a force of repulsion between two charges that are the same. Okay, take a look at this picture. This shows a child moving down a plastic slide in a park. And you can see that his hair is all sticking out. So the question is, what is happening here? Well, this is due to static electricity, and this is what we're going to explore in this video. So first we're going to take a look at conductors and insulators. Okay, now metals are good conductors of electricity, and that's because electrons can easily flow through metals. Objects such as plastic and glass are insulators. That means that they do not conduct electricity, and that's because electrons cannot move through them. Now, a good example of an insulator is cloth. Like everything, cloth is covered with electrons, but they cannot move through the cloth because cloth's an insulator. So now I'm going to bring a plastic rod over to the cloth, and I'm going to rub the plastic rod with the cloth. Remember that plastic is also an insulator and is also covered with electrons. Now, if we rub the plastic rod with the cloth, electrons can move from the rod onto the cloth, and that means that the cloth has a negative charge. The rod is now left with an equal positive charge. So let's imagine what would happen if we did this again, but with a metal rod instead of a plastic rod. Well, if we rub the cloth against the metal rod, then electrons can move onto the cloth just like before. But metal's a conductor, so now electrons simply move onto and up the metal bar, and they neutralize the charge. So the metal will not have an overall charge at the end, and that's really important. So remember that static electricity only works with insulators and not conductors. Now, this shows you two plastic balls hanging on string. This ball's got a positive charge, and this one has a negative charge. Now, opposite charges attract each other, so that means that there's a force of attraction between these two plastic balls, and they move closer together like this. Now, if we have the same charges, then they repel each other, so two positively charged plastic balls would move apart. So let's go back to the question I asked at the start. What's happening to this child as he moves down the plastic slide? And why does his hair stand on end like this? Well, as he moves down the slide, the electrons move from the child onto the plastic of the slide. So that means that the child now has a positive charge. Because his hair is positive, that causes the hairs to repel each other, so they move further apart. Now, if this child touched a metal object, electrons would move onto the child to neutralize the charge, and his hair would return to normal. Okay, so hopefully now you can describe how electrons can be moved from one insulator to another if we rub them together. And then go on to explain how there can be a force of attraction between opposite charges and a force of repulsion between two charges that are the same.
All right, so we need to think about what the two different particles that we've been talking about here, protons and electrons, what will they do to each other when they get close to each other? So here we have two protons. What are they going to do to each other? Well, they are the same charge, as you just saw in that video clip there. They are the same charge, so they will repel each other. Anything that is the same will repel something that is the same as it. These guys are both negative electrons. They are the same as each other, so they will again repel each other. And then we have a third option here, which is two different charges. We have a proton on the left and an electron on the right over here. Protons are positive, electrons are negative, and so opposite charges will attract each other. You may have heard the term opposites attract before. That is definitely true in the case of protons and electrons. Opposites will attract each other, so these guys, when they get close to each other, will tend to move towards each other and stick to each other. All right, so let's fill this in our notes. Law of electric charges. Unlike charges attract, So those two guys will attract each other, and like charges repel. So those guys will repel, they will push away from each other. Those guys will repel, they will push each other. So protons push away protons, electrons push away electrons, but protons and electrons, when they come near each other, they will be attracted to each other. Okay, so in the video clip that you saw, they also talked a little bit about the idea of insulators and conductors. And when we're talking about electricity, this is a pretty important idea here, the idea of insulators and conductors. Generally speaking, conductors are things that are metal. Metal things conduct electricity. You may remember this term being used, this idea of conducting, when we talked about metals before, when we talked about heat. Metals also conduct heat. It's basically the same idea. It's the idea that this thing will either heat or electricity will move right through it. So we have metal here, that's a conductor. That wire right there, electrical wire, obviously conducts electricity. We have a piece of metal right there that will conduct electricity. We have a metal spoon right here that will conduct electricity. But these guys here, that one and that one and that one and that one, those guys are insulators. To insulate something means you don't let it go through. So those guys will not let electricity go through them. So we have conductors and insulators. So conductors they allow electrons or electricity to flow. Remember, electricity is the flow of electrons. That's why they both start with the same letters. And these include metals, and this is something that we will talk about next, which is current electricity. That's, I think, what you usually think of when you think of electricity, like the things that batteries do and the stuff that comes out of the sockets in the wall, the things that are used to run your phone and computers and all sorts of electrical equipment like TVs and radios and all that kind of stuff. That is what we call current electricity. And just like a current in water, a current in a stream, that means that it's moving, that it's flowing. So the electricity is kind of moving through here. Now, the thing that we're talking about today, though, is static electricity. And that is something that usually happens in insulators where they do not allow the electrons or the electricity to flow through. This usually happens in what we call nonmetals, or things that are not metal. This includes things like plastics and glass and pretty much everything else you can think of, rocks and cement and all sorts of different stuff that is just not metals. And this is what we call static electricity. You probably, as I said, you probably know the word current means like moving water and also moving electricity. Static, you've probably heard that word before, but you might not know that static means not moving or not changing. When something is static, that means it's kind of staying where it is, or it's staying the way that it is. So static electricity is electricity that's kind of stuck in place. So static electricity is the imbalance of positive and negative charges. Well, what does that mean? That means that maybe we have a buildup of some positive charges here in this little baby's hair, and maybe a buildup of some negative charges here. And remember, opposites attract. So those positive charges in the hair here are going to want to be attracted to the negative charges in the little teddy bear there. And that's why they stick together. So here is the idea. How do we build up this imbalance of charges? Because generally speaking, atoms are what we call neutral. Very important point here. Atoms, generally speaking, are neutral, meaning that they don't have an overall charge. The reason for that is because atoms usually have the same number of positive protons and negative electrons. So for every proton, there's an electron, and they cancel each other out. And so the positive charge of the proton cancels out the negative charge of the electron. And so atoms are usually neutral, and you are usually neutral. Things are usually neutral because they're made up of neutral atoms. So in order to create an imbalance of positive and negative charges, we have to make some we kind of have to deneutralize these atoms. We have to give them a charge in some way. Well, how do we do that? Well, this can be kind of surprisingly simple, actually. There's no real magic going on here. Basically, the idea is you guys have probably all rubbed a balloon on your head, right? And notice that it sticks to your head, or it makes your hair stick up, or it'll stick to the wall. Well, how does that work? Okay, so first of all, friction causes the electrons to move from your hair to the balloon. So you have all of these little atoms in your hair that look just like this atom right here that we already labeled. And remember, that atom has positive protons on the inside and negative electrons on the outside. So when you rub it, you can actually rub off these electrons. And so those little electrons are all popping off here, getting rubbed off and going onto the balloon. Well, let's think about that now. So you have a bunch of extra electrons over here. So what's the charge going to be on the balloon? Well, it's got a bunch of extra electrons, so the charge is going to be negative. Sorry, that's a horrible minus sign right there. So I'm going to scribble that out. But here is the other side to that coin here. Here's the other side to that idea. Once we have removed this electron that used to be here, right? Now what's left? Well, all that's left is a positive proton. So now you got a bunch of positive protons, a bunch of positively charged atoms left in your hair here, and you have a bunch of negatively charged atoms over here, all these minuses over here, and all these pluses over here. And what do opposites do to each other? Well, opposites attract each other. So all of these positively charged atoms over here are going to be attracted to all the negatively charged atoms in the balloon, and the negatively charged atoms in the balloon, well, of course, they're going to be attracted to the positively charged atoms in your hair, and then they're going to want to stick together. So that's basically how that works. That's sort of the most simple version of this, but all of it's exactly the same. That's the reason why your clothes stick to you sometimes, or socks come out sticking to your clothes in the dryer and stuff like that, because something is positive and something is negative. And the key thing is the idea of stealing electrons. It's the electrons that go from one place to another. Remember, this is electricity. It's all about electrons. So it is the electrons that get stolen. But when electrons get stolen, that means wherever the electrons go to is more negative, and wherever they come from is now more positive. And that's about it. That's how static electricity works. So we have electricity is the flow of electrons due to the force of charged particles. Protons are positive and electrons are negative. Do yourself a favor and get that stuck in your head. Learn that right now, because that's something that we are going to be talking about pretty much for the rest of the entire year. Like charges repel, so protons repel protons, electrons repel electrons, but opposites attract, so protons will attract electrons. We learned about conductors, which allow electrons or electricity to flow. Conductors are metals, and they are usually involved in what's called current electricity, or the flow of electricity. But what we were talking about today was more about insulators. They do not allow electrons or electricity to flow. They usually are non-metals like plastic, glass, and things like that. They are involved in what we've been talking about this week, which is static electricity, and it is usually friction that causes electrons to be stolen from atoms. So think of rubbing a balloon on your head or rubbing your feet on the carpet, things like that. Friction is usually the culprit here that steals electrons and makes it so that one thing has more electrons and therefore is negatively charged, and the other thing has less electrons and therefore is positively charged. And so they will attract each other, and we will do all sorts of experiments and things like that, including using the Van de Graaff generator, which you guys always ask about in class this week. So I will see you then.